Hey guys, welcome back to my YouTube channel, and today I'm making a video on 507022 paper 2 theory, and this is the latest October-November 2019 paper. In case you haven't checked out my previous videos where I covered the entire section A in my part 1 and 2, so you can check it out over there. And today I am here with another part, and this is from question number 6, that is section B. So without any further ado, let's get started. The question number 6 says, Butanoic acid C3H7COOH is a carboxylic acid. Draw the structure of butanoic acid to show all the atoms and all of the bonds. As this is butanoic acid, first of all, butanoic, okay, it's already mentioned over here, it's carboxylic acid. However, we can get to know from the name as well, butanoic, all the chemical bonds, all the chemicals that have this suffix OIC is a carboxylic acid. Okay, so butanoic acid is an organic compound, and of course a carboxylic acid, because it is buta, that means BUT, is always used when there are 4 carbon compounds. Alright, so this is how it is. And OIC means carboxylic bond, means it has double bond of oxygen with C. That is C double bond OOH. It's like that, even it's written over here. That means this C has a double bond with this O. This C has a double bond with this O, and a single bond with with the other O. And this O has a single bond with H. This is how it is. So you can draw it like 3 C's. Alright, first and attach hydrogen with it, then draw the 4th C and draw double bond with O above it and OH. O and then bond O, H with O. Moving on to part B, describe the movement and arrangement of the particles in liquid butanoic acid. Liquid butanoic acid means they will be sliding over each other because it's liquid, and arrangement is going to be random arrangement because once again it's liquid. It's very basic states of matter kind of question, kind of part actually. This is related to organic chemistry. Part C, the melting point of butanoic acid is -4°C. The boiling point of butanoic acid is 166°C. Deduce the physical state of butanoic acid at 0°C. Explain your answer. So the physical state at 0°C. Now as we can see over here, melting point of butanoic acid is -4°C. That means if it is, for example, above -4°C, then it will be like if it is below 166, if it is above 166°C, it will be in steam form. And if it is below 166°C, that means it's in liquid form. So either it is gas, if it is above it is gas, and if it is below it is going to be liquid. And then about melting point, if it is -4°C, that means if it is above -4°C, it is in liquid form. And if it is below -4°C, that means it is in solid form. Ultimately, if we see over here, we are talking about 0°C. 0°C is below 166°C. Till now, we recognize it is a liquid. However, if we look at -4°, the question remains that either it is a solid or liquid. And then if we see at -4°C, as -4°C is below 0°C, that means it is in liquid form. 0°C is the liquid form of that acid, of butanoic acid. An explanation, I give you such a long explanation, you can just shorten it up and write it like it is below the boiling point and above the melting point. That's how it is. It's just one mark and super easy and super mark gaining question it is. Now part D seems a bit complicated, but it's calculation based. The equation of the reaction of Butanoic acid with sodium carbonate is shown. 2C3H7COOH, that is Butanoic acid, plus this is sodium carbonate, is equals to the salt that is formed with carbon dioxide and water. Alright, a student added 5.28 gram of Butanoic acid and 56.0 centimeter cube of 0.5 mole per dm cube of sodium carbonate. Show by calculation that Butanoic acid is in excess. First of all, calculation showing is important. You are supposed to show what steps to take. And yeah. So first of all, we are simply about to find the mole of Butanoic acid, and how are we going to find it? Simply 5.28 gram is the mass. See, moles is equals to mass upon mR. And the mR of Butanoic acid you can calculate, that is 12 for carbon, 12 into 3 plus 7 plus 12 plus 16 plus 16 plus 1. Well, if you will do this, and you can take help of the periodic table, which is definitely given at the end of this paper, and you can do it from that easily. You will calculate it. You are going to calculate it is going to be 88, and then you're going to do 5.28 upon 88. Why 5.28? Once again, it is mass upon mR. Why mR? Because it's the part of the formula, and mR is 88. So 5.28 upon 88 is equals to 0.06 moles. Then for this, what you're going to do after it is find the moles of sodium carbonate. Now the mole of sodium carbonate, you can find it from the data given over here. Like we have the volume over here. See, first of all, the volume is in centimeter cube. Make sure you're going to convert it into dm cube by dividing it with 1000. Why do we have to do it into dm cube? Because over here we have got dm cube value. Over here we got this concentration which is having dm cube in it. Alright, so it is going to be 56 upon 1000 multiplied by 0.5. And in this way you're going to find the moles. Moles is equals to volume into concentration. And that's how it is. Then after it, we are going to simply find, you can say, the ratio. You're going to just multiply it with 2 and you can get the answer easily. That's how it is. Also about this question, I would like to give you a tip. Either you can do one of them, first of all. I told you both the ways right now. You can either multiply by 2, that is the first answer that we found, 5.28 upon 88. Either we can do this and multiply it by 2. Otherwise, in other case, you can find sodium carbonate moles and then you can divide it by 2. Why? Because we have the ratio. As I told you right now, we're going to use the ratio thing and do it. 2:1 is the ratio. So it depends on however you want to do it. But make sure you show the entire calculation part. Moving on to part E, magnesium reacts with butanoic acid. The products are magnesium, butanol, and hydrogen. Construct the equation for this reaction. It is going to be Mg plus, this is butanol. Okay, magnesium butanol is the product, and we are talking about magnesium, that is Mg plus butanoic acid is C3H and C3H7COOH, which is equals to the product, equals to not arrow, I meant to say arrow, plus H2 and C3H7COO2 whole to Mg. And you are going to balance it. After balancing, you are going to get 2 behind the butanoic acid, that's all. And always, as I have been repeating this in all of my videos, that balancing is really important. Questions nowadays, earlier you'll find a few questions that would be like, it would have 2 marks, one for the equation and the other for balancing, but now we have 1 mark. So if we do not balance the equation, or if we do any mistake in the equation, then you're going to get 0 marks. There is no flexibility in this. F. One method of determining the pH of aqueous butanoic acid is by using a pH meter. Describe a different method of determining the pH of aqueous butanoic acid. For this, you're going to use either a universal indicator, because we have used pH meter, so we can't use that. We are going to use a universal indicator and then match it with a color chart that is provided in the lab and all. So that's what you're going to write over here. This is a 10-mark question, and it's, I guess, really easy. Just you need to be focused and you need to be vigilant while solving it. And yeah, that's all for this video. I will be coming up with the other part and completing the other part of the paper as well in the further videos. Make sure you like, subscribe my channel, and hit the bell icon. October, November right now is approaching, and I'm sure you're all practicing very hard. If you have any kind of query related to this video or related to any other paper, or you have any question that you want to ask, you can do that in the comment section down below, and I'll try my level best to reply to everyone and make sure to fulfill everyone's requests related to papers and all. All you have to do is keep working hard, and best of luck.